All right, gang. I appreciate your all's patience and understanding while I've been out. I'm going to go through the review that you were assigned to do in class, either on Wednesday or Tuesday. And hopefully this will help you be ready for your test either on Thursday or Friday. If you have any questions, feel free to send me an email or text through Remind, and I'll be happy to help. So this first question is introducing that idea of I. Okay, so what we know about I is that the square root of -1 is equal to I. So when I go and solve this equation, to get rid of this square, I do the opposite, and the opposite is taking the square root. And I do that on both sides. When I take the square root, it cancels this guy out and I just get an x. Now this -144, if you type that in your calculator, it'll tell you error. Or Desmos says undefined, as you can see right here. So what I need to do is break up this -144 into something that I can do either in my calculator or in my head. So I'm going to take it and make it the square root of 144 and then the square root of -1. So when we multiply square roots, we multiply what's underneath the radical. It's called the radicand, and 144 times -1 is -144, which takes me back up to where I started. So when I start actually simplifying this, in my calculator, I can put the square root of 144, and it'll tell me that the answer is 12. And so I'm going to get this being x equals 12, and I know that the square root of -1 is I. So this is I. But the square root of 144 isn't just 12, it's actually plus or minus 12 when I'm solving an equation. So this answer right here is going to be plus or minus 12i. Okay, so this is the same type of question, but with a different number. So I'm going to do the exact same process. I'm going to take the square root of both sides. On the left, I'm going to get x, and on the right, I'm going to get the square root of 36 and the square root of -1. So this is going to be x is equal to plus or minus 6, and then I. Now, if you want to go straight from here to here, then that's cool. Plus or minus 6i would be your answer. Okay, the next question is easier than you think. We are going to combine like terms. So 7 is a like term with -9, and the operation between everything is plus. So all I'm going to do here is 7 plus -9. Then I know that the i's go together, just like if they were variables and it was x's. So this -i and this positive 8i will go together. -i is like -1i. So this guy is really like there's a 1 right there. So what I'm going to add on to that is plus -1i plus 8i. So then I can type those things in my calculator. 7 plus -9 is -2, and -i plus 8 is positive 7. So positive 7i. In complex numbers, it's always a plus bi. This is your constant, and this is your imaginary term. All right, so same type of question. The 5 plus the -7 go together. And you don't have to write this down. This is just what I'm doing to show you guys. And then -i plus 8 go together. So that's plus -1i plus 8i. So 5 plus -7 is -2. And then -1 plus 8 is positive 7i. So that would be my final answer. Okay, we are going to double distribute. You may have been taught FOIL. I do not teach FOIL. I teach double distribute. I am going to take the very first term here, this, and I'm going to multiply it by each of these terms in the second part of the equation. Then I'm going to take the second part of the first term, and I'm going to multiply it in both of these places. So I'm going to distribute each term twice, double distribute. So it looks like this. 3 times 3 is 9. So I'm multiplying. 3 times 3 is 9. 3 times 4i is positive 12i. Then I'm going to go and do my negative 4i. Negative 4i times positive 3 is negative 12i. Negative 4i times positive 4i is negative 16i squared. So what I notice is that these two are opposites, which means they're going to cancel out. The 9 is just going to come down, plus, and then this negative 16i squared. Okay, so if the square root of negative 1 is equal to I, then if I square both sides, then negative 1 is equal to I squared, which basically means anytime I see an I squared, I can replace it with the number negative 1. So this is plus negative 16 times negative 1. And negative 16 times negative 1 is positive 16. So I end up with 9 plus 16, which is 25. Double distribute. This one is the same, but it's only a single distribute, so maybe a little bit easier. So I'm going to take this 8i and I'm going to distribute it twice. So it's going to be 8i times 7, which is 56i, and 8i times negative I, which is going to be negative 8i squared. But remember, the square root of negative 1 equals I, so if I square both of those, negative 1 is equal to I squared. So that means that this I squared gets replaced with a negative 1. So I end up with 56I plus 8, because that's negative 8 times negative 1 is positive 8. And then remember, we like it to be the real number first, and then the complex number second. Okay, this question is a lot simpler than you think. We did not learn completing the square. If I were there in person, we would have, but I wasn't. So we didn't learn how to do that. It's pretty cool. Maybe we'll learn it before the end of the semester. But it takes this form of the equation, which is standard, and it rewrites it in this vertex form. So when we use completing the square and we rewrite in vertex form of the equation, so this is vertex, then it helps us because we can identify the vertex of the graph. So it's vertex, vertex on this one. Your test is going to look a lot like this review. In fact, it'll be the same questions with different numbers. And so a question like this that has the drop downs would be the same drop downs. So vertex, vertex. Okay, so this question is asking what you understand about the quadratic formula and what it tells us. So the quadratic formula will tell us the x-intercepts. So that tells me if it's an x-intercept, it tells me where it's going to cross the x-axis. And what that tells me is what the x-intercepts are. So that's what quadratic formula does. It tells me x equals, because the formula is x equals negative 3, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that big part of that is the x equals part. So those are x-intercepts. That's where I cross the x-axis. Okay, explain why the graph of the quadratic equation x squared plus x plus 5 crosses the y-axis but doesn't cross the x-axis. So when I graph it on Desmos, this is what it looks like. I can see that it crosses 5, and it does cross. This is my y-axis here, but x is way down here somewhere, and I don't cross the x-axis at all. So what that means is that the solutions, if I were to plug this into the quadratic formula, my solutions are going to be imaginary. It means that they do exist, but they're not real. Real is when I cross the x-axis, so this would be my x-axis. So this answer here is... So our answer is B. The graph does not cross the x-axis because there are no real solutions to the equation f of x equals 0. The domain is all real numbers, which is true. We go left to right forever. And we cross the y-axis at x equals 0. So this ordered pair right here is 0, 5. So that does cross at x equals 0. All right, so we're going to do a quadratic formula problem. I think I've chosen the problems to not have any imaginary solutions and to not have any weird radicals. So we have to remember that a is the coefficient of x squared, so a is 1 here. B is the coefficient of x, so b is 12. And c is the constant, so that's 36. So our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we are going to basically just copy that guy and we are going to erase all of those letters and put in their numbers. So I'm going to take out this negative b and this b, and in its place I'm going to put what b equals, which is 12. And then for the a, I'm going to take out every place that I see an a, which is right here and right here, and I'm going to put what a equals, which is 1. And then any place I see a C, like right here, I'm going to take that out and I'm going to replace it with what C equals, which is 36. Then I should be able to type that whole thing into my calculator and it should tell me an answer. Now the thing is that I have this, this here plus or minus bit. And so I'm going to have to type it in once with a plus and once with a minus. So let me do that on Desmos and paste it in here for you. Okay, so on this one, we did not get two different answers. The reason that happened is because what we did underneath this radical, which is called the discriminant, ended up being 0. So whether I add or subtract 0, I'm going to get the same answer. So here, my answer would just be x equals -6. I would not have to put 2 in. All right, so now we get to talk about the discriminant. The discriminant is the part of the equation, the quadratic formula, that is underneath the radical sign. So remember, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Our discriminant is this piece right here, this b squared minus 4ac. So b squared minus 4ac. If that number is positive, so if this is positive, then I get 2 real solutions. If that number is negative, then I get 2 imaginary. If that number is exactly equal to 0, then I get exactly 1 real solution. So I need to know a, b, and c, just like I did for the quadratic formula, but all I have to do is b squared minus 4ac. And then I have to see, is it positive, negative, or does it equal 0? And then based on that, I can determine whether I have 2 or no, or exactly 1 real solution. So here my equation is 16q squared minus 40q plus 25 equals 0. So I have b is negative 40, so that's going to be negative 40 squared minus 4 times a is 16 times c is 25. So I plug that into my calculator and I end up with 0, which means that we have exactly 1 real solution. So 1 repeated or real solution. Okay, so same type of problem. I need to find my a, b, and c. A is 1, b is 3, c is 1, and I want b squared minus 4ac. B squared is 3 minus 4 times 1 times 1. I can plug that into my calculator, but I can also do this one in my head. 9 minus 4 gives me a total of 5. So since the discriminant is 5 and that is positive, then I'm going to have 2 real solutions. All right, so here we go again. We have a is 3, b is 7, and c is 11. So we have 7 squared minus 4 times 3 times 11. That gives us 2 complex solutions that are not real. So that would be this guy right here. That's because this is a negative 83, because it is less than 0. That makes it have complex solutions. All right, this one just asks, how do you plug this into the quadratic formula? So we know that A is 2, B is -1, and C is -15. So we have x equals negative b plus or minus the square root of b squared minus 4 times 2 times -15 all over 2 times 2. So the first thing I notice is that this can be turned into a +1. -1 can become +1. So I'm going to change that to just 1. All right, so that lets me eliminate this guy. That's not in there correctly. I also know that the number underneath this radical here, it's 4 times 2 times -15, so that eliminates this guy. And let's see, what are the other differences that we see? It's a -4, not a plus, so I can eliminate this guy. Now we just have to determine, is -1 squared right here, is that going to be 1 or is that going to be -1? Well, -1 times -1 is +1, so that means that my answer should be E, because I've got +1, +1, minus 4 times 2 times -15 over 2 times 2. All right, this one's old news. We have done this before. This time, though, it does want the ordered pair. It even tells us here, type an ordered pair. So we're going to use this guy. It's going to go -1, 3, comma, -3, 5 is what you need to type in for Savas. So we just graphed exactly what this said right here, and then looked at where they intersected, and I clicked on them and it told me. All right, so this one, they don't cross. So if they don't cross, guess what? There is no solution. Okay, so this one, once I graphed it correctly, because I had to graph this one 4 times, I see that it only intersects in one place, and because I have an x and a y, my solution is going to be that entire thing, 6, comma, -103. Okay, this one, because I'm actually solving for x, so it's not y equals and y equals. I'm using a graph in order to solve it, but I'm not actually solving for 2 systems. I'm just using that information. So because the equation that I'm solving only has x's, x, there are no y's in the equation at all. I'm only going to use the x values. So my answers here are going to be -1, comma, 3. If it happened to have been instead of an integer, these were integers, if it was a decimal, round it to 2 decimal places. Okay, so this one, it wants me to take this equation and this equation and graph and see how many points of intersection there are. This one doesn't cross, and so my answer is going to be no points. No points. Part B is asking how many points of intersection we have, and we're going to say exactly 1 point of intersection. This one was a little bit tricky to find on the graph. I did have to zoom out quite a bit and kind of scooch around to get that actual intersection. Okay, I'm starting to run out of room, but on this next one, we can see that they intersected exactly 1 point. So you get the idea. Either they're not going to intersect like this one, or they're going to intersect at 1 point exactly. Okay, so that's everything that should be on your test tomorrow. Please review this. Make sure that you know how to do these things. Use this as a reference so that you can do well on this test, and I will see you guys the week of Thanksgiving. Thanks, and thanks, Mike, for sending your email. That's what prompted this. So if you all see Mike in class, B3, I think, tell him thanks. Otherwise, you wouldn't have gotten this.